You're not the first one today. And now hello YouTube as well. I think I will start implementing in 2 minutes. That it's now, yeah, let's try to start in 1 minute at 18.10. And here I'm just testing this. This can later be improved a little bit once the first minute passes. All right, starting in 25 seconds. Add color contest stream. I don't get the question. No, this is not add color contest stream. This is Google Code Gym. You can get a link. Yeah, everything seems to work. And we should start. Start reading the first problem. We need to get close to some unknown C. What are the limits? K is big, but n is always small, so we will choose something between two values. Let's say that the chosen already tickets are 137, those are taken. Then I think I will guess 5, maybe 10 is good. No, 8 is better. I will get 8. I will say 8, and maybe I will say 5. Then if the answer is 5 or the answer is 8, 9, 10, I win. But that's just... No, it's instead of 5, it's better to say 6. Because for 5 and 6 I will win. If the generated number is 5, then I'm the closest. In general, what happens when two consecutive numbers already chosen are 10, 20? Should I say always 19? I can say both 11 and 19, and then I take the whole range. Or I can say just 19, and then I will get half of the range. Let's just something smaller, like if 10 and 14 and I say 13, then how many numbers are good? For 12 I'm the closest, for 11 I'm not, so here 2. If it's 10 and 15 and I say 14, then for 13 I'm closest, for 12 I'm not, so 2. It's always size of this difference divided by 2. So if two consecutive already taken values are a and b, then I can get b minus a divided by 2. I can also take everything greater than the biggest number, everything smaller than the smallest number, and stuff between according to this formula. Unless I choose two values there, then I will grab the whole range. I think that's enough of a logic. Let's do something different for this first problem, because I didn't open my IDE. Let's just code it here. Shouldn't be a big deal. But later I will switch for my own IDE. They always have this format where you need to say case. I was going to use, I will use scanf and print. It's harder to read for you, the viewers, but it's easier for me to use. Right, and now we can focus on a single test case. Can numbers repeat? I think so, yeah, they can. They can, but I don't think that will be any bad for me. Oh, and the timer is messed up, right? If you want something from me, at me. Use in the chat at Eric too. I will then see it. So sorting. And how many numbers? Answer will be how many numbers I can take. I will at the end print it as a double and divided by k. All right, I should find two best possibilities to use a single number. So this will be a collection of possibilities. What happens if I put a single number there? In particular, if I go below the smallest value, if that smallest value is 5, I will get 4 values for myself. Same thing at the end. And now I'm looking at two consecutive values, not best size, A size. So the first one is X, the second one is Y. And now I use the formulas from below. Either I can take the whole range, like this, like from 10 to 15, I will grab 4 numbers in between. Or I can grab half of it with a single value. Let's sort decreasingly, and two first values are biggest. So those are two best single choices, and answer was the best double choice. I wonder how the system works. I didn't use this run test so far. In the meantime, I can prepare my own environment. Do I have here something like Google Code Jam directory? Okay, we have some output 0504000025. Looks correct. Then I want to submit this. Submit. That's 7 minutes. Where was I? Google Code Jam. I think this is the proper directory. Sample failed? Miss the hash? No. Okay. I see. Clear lesson is I should copy paste my templates instead of writing the code from scratch. That doesn't count. Come on. Nobody saw it. Okay, 8 minutes then. We move on to the second problem. This one I will do in my own IDE. Thank you, chat. If this wasn't streamed, then I would anyway just copy paste my templates instead of writing stuff from scratch. 2021 is roaring because it's two consecutive values concatenated. Can be two or more. Find what the next roaring year is going to be. Again, some mathy problem. When we get any number like this one, I would say that it's good to iterate over some prefix here. Let's say that 68 will be an unchanged prefix, then this is candidate for the full number, but this is quite big. Instead, we can start with 69, but that doesn't help, I guess. We can start with 70, doesn't help either. We can go with something 3-digit long. I think it only helps if you get more digits. Okay, so they started here with 7. And then here's the idea. Either we just start with this unchanged prefix, or this value plus 1. Maybe like here. If this is the input, then this is a very good possible output. If instead this was the input, 68 and then a lot of 9s, then this one wouldn't be bigger. Instead, we need to start with 69 and continue 70, 71. Alright. But if that doesn't work, then I think next candidate, but likely this will not work because of the length of the full number. The next candidate should be, in my opinion, something that will exceed the number of digits. Something close to 99. Can be this. Or 90, start with 98, then 99, 100, and so on. I think that prefix will coincide with some prefix of the given number, or this prefix plus 1, just to be bigger than the given number if the suffix is big, or we will start with something like 99 or a little bit smaller, like maybe 97, because eventually here we will get a different number of digits. And the lowest I should go is something like maybe 81, not even that. Let's investigate 91. If I start with 91, then we get this, 98, 99, and 100. This seems to already be bigger than 10 to 18. So that's too much. I will iterate over a prefix that will remain kind of unchanged. I will consider that I start from this plus 1. And also I will consider starting from 99, 98, and let's say 20 next values down. And that should be enough. Let's see if for samples that's enough. Here I not change this. I want strictly greater than here. 21 is better. For this input number, I consider not changing this prefix or going this plus 1. Sure, and then here 1. I don't change this. Yeah, I will test all possible prefixes, but I really want my own IDE this time. This is 1C. The problem is roar. I don't need that, let's say. And let's do some coding. Oh, by the way, we're solving problem B right now. It makes it easier later to find stuff when watching the stream on YouTube. Okay, this thing is long. I hope that I will not exceed long. Maybe I need 828 for everything. And that might come handy. But I will just test. Yeah, I will use 828. So long, the given year y. Should I read this as a string? Should I also repeat? I wonder if a number has like 3 digits. Should I consider also making something of 4 digits long and then repeat it? No, that should be stupid, right? Yeah, because 10, 11 is for sure good. Well, not always. What about this? But I don't need to go twice the size. What for 9? For 9, the answer is 1, 2. Right now my solution doesn't see this, does it? I need to think about that. It's kind of better than seen? No, but I'm just used to it. My program will find a proper answer because it will try a prefix of 9 and 20 previous prefixes, but it seems to be a coincidence. I didn't think about it while coming up with my solution. The statement in short is, given a number y, find the next number that is a concatenation of consecutive values, like 2021 is a concatenation of consecutive values. We can use more than 2. Well, it's fine. I will always consider a prefix of 1, because from 9 I go 20 times below. And I think that should be enough. Or is it? Maybe I should, no matter what the number is, when testing some prefix, here maybe I should also try to put 100. What about that? If this is a big number, like only 9s, then this will be the best we can do. All right, for every prefix I'm going to test big values like 999 and a little bit smaller, and also 100, and also this prefix and also this prefix plus 1. What do we type here? From 0 to pref. Okay. I will have a function that will try this starting value, test of x plus 1, also big ones, and a power of 10 and something close to power of 10. Let's see what test does. Here long is enough. Well, I need to cast. There is this function. Oh, you don't see it. It will be here casted to int 128. Does it compile? It does. Cool. Value is initially x. Do at least once something and repeat it while value is smaller or equal than y. Not return value. There will be some answer. Value is smaller than answer. The function test is supposed to try this as a prefix and keep repeating it increased by 1. Here we do x++ and we concatenate. I need to say that value is power of 10 times value plus x. This power of 10 is related to length of x, this new length of x. Is x. That should do the trick. Right, for 1 it will do 1 repetition, for 10 it will do 2 repetitions, for 99 2 repetitions. Yes, it's all fine. We test this and we then test stuff around power of 10. I'm a bit scared about values bigger than 10 to 18 because I don't want int 128 to overflow. So let's do this trick. If you're bigger than 5 times 10 to 18th power. Because then I think x squared will be a little bit too much. Sometimes, maybe, I don't know. 10 is 1. So first we consider a very small power of 10, which is just, I think, this. Then we multiply it by 10. And we do like 30 repetitions, let's say, just in case, of testing 10 minus I. I then need to print the answer . But there is no cout answer or print answer will not work because answer is int 128. It's not really well supported in C++. All this. Append a digit. This digit. Reverse and print. By dividing a number by 10, obviously you can get digits from the end. Oh, team budget. Thank you for the raid. A big one. I'm solving problems from today's round of Google Code Jam. And I'm doing just fine, assuming that I get this right. Submit. So perfect time for the raid. Fingers crossed. I didn't pass the second test. But I passed the first one, which means that something is wrong once I hit very big numbers. Where? Why? What? In line 25. Why is this long? I wanted to use int at 128. This is long, that's fine. Stupid mistake. I should have just tested for something big. Right. I'm disappointed in myself. Code of Advent. It's shorter, just a few rounds of each 2 or 3 hours and much more difficult. But yes, it's still like competition. Okay, now passed. We are at 26 minutes. That puts me at like 2nd place in the contest right now. Maybe 3rd, maybe there were some more people who got first 2 problems very fast. But I'm not slow. I made stupid mistakes, but I'm not slow. If I do this fast, then I will get the time enough for the 1st place. All that being said, again, this round was easier because some people already advanced from the previous 2 rounds. The last problem, double of nothing. Double or nothing is, you know, when you have some kind of bet where either you lose everything or you double your money. In case you didn't know. I solved AB and now C is left, the 3rd problem. We need to transform first number into second one. We can multiply by 2, so append 0 at the end of the binary representation, or take the bitwise NOT. Okay, compute the smallest number of operations needed. It's interesting that in this final round, final elimination round of CodeGem, they decided to use so many hidden verdicts. I guess that for test set 1, brute force is enough, where we will never go through very long numbers. And here we need to be smarter. So let's try to be smarter. Doesn't make sense to multiple times in a row multiply by 2. Let's say I have this number, and let's say this. What happens when I just multiply by 2 once, and now I do the NOT? Then it's like adding ones at the end of the number, of the negated number. If instead I started from this and multiple times multiplied by 2, then I got that, then this, and now negate that. 1101, and so on. Instead of that, it's like I was able to add ones. Okay, then I should look at this as like sequences of ones and zeros. There are right now 2 ones. How can I mark it? Let's say there are 2 ones, 1 0, 1 1, 1 0, 3 ones. What I can do is get rid of that and flip the state of each of those. So more like, let's keep track of just sizes of blocks. This means that there are 2 ones, 1 0, 1 1, 1 0, 3 ones. I can drop the first number, and I can, assuming that the number of numbers is odd, then this number represents the number of ones. Then an operation can be to add a 0, so it will create a 1 there, and then it will keep increasing it. With 1 operation I can get this, with 10 operations I can get that, 10 zeros at the end. Then when I cut, I will just drop this value. This is again the number of ones, because everybody flipped, and now I can append some zeros here. The state is just the current interval, and it's important if there's even or odd number of them, because it affects the last type of the last value. I think what will happen is we will transform the first value to this sequence, like here. This is a bad example because the answer is 0, but this is a better one. We have a sequence with 1 3 1, and we want to get a sequence with just 3. And we can kind of add values at the end, and we can drop the first one. Then this is not useful at all. If instead I wanted to get 3 1, then maybe, so this means going from that to 1 1 1 0. This is 1 1 1 0. Then it's enough to just cut the first value and you have this sequence. And indeed, cutting this and negating the rest, it's 1 1 1 0. Seems easy. Relatively easy. I will have one sequence of block sizes. The starting value, the starting binary string, it gives me a sequence of values. Let's say it's 2 4 5 1 2 1 1 3. It means there are 2 ones in a row, 4 zeros in a row, 5 ones, and so on. And let's say I want to get at the end 2 1 1. I wonder if this is possible. 5 2 7. Then it would be nice to use the fact that if after I drop those, I get kind of the same stuff here. And I think, depending on the parity of the number of elements there, I might be able to increase this value. If this represents the number of zeros, then multiplying by 2 increases this value. I will try every alignment where to put this new sequence. And I will see if all numbers here in the common suffix of first sequence and prefix of the other, if they match, except for the last one, and usually I can make the last one bigger. I couldn't make this change because it would mean cutting numbers from the end. And I cannot do that. Can there be a case where I cannot achieve this? Let's see. If I start with 2 1 1 3 and I need to get to 1 1 5, is this possible? This is number of ones, zeros, ones, zeros. So here it's possible. I just multiply by 2. With 2 operations I can get from here to that. But if I insert one more value there, now 1 zeros, 1, this is the number of ones, so I cannot just multiply by 2. I need to negate, and this cuts the first value and I get something completely different. This is the only case only case where I can't increase last. So also there could be something there and I cannot achieve that. Should I even say that? Oh, it's also important what's the number of dropped elements versus here, those. Every time when I negate, I switch to the next value and I drop one. So this suffix that I create, a new values, it cannot be longer than this sequence. All right. And then if sizes are the same, then maybe I cannot increase this. Why not add 2 zeros? Where? Here? I mean, every time you negate, so you start a new value, 2117375. Yeah, I cannot do that because this is the number of ones. This sequence is a representation of 2 ones, 1 0, 1 1, a lot of zeros, and finally 3 ones. And from this we want to get the same binary string but with 2 ones at the end. Multiplying by 0 will not increase this by 1, instead it will just do that, and this is bad. If the last number represents zeros, then we can increase it. Other than that, we cannot. Yeah, so I will read the 2 binary strings. I will change each into such a sequence. I need to think what happens when I get 0, so I negate everything. Because that, like when I remove the last element of the sequence, the only element, instead of an empty sequence, I get element 1. Oh, but then I cannot multiply it by 2. I need to negate it. So if I have something like this represents 5 ones, then I get 0. This is a fake element that I cannot really use. Are those positive? I can get 0. From 0, then I can get 1, and only then I can continue. And this is the number of ones, so I cannot increase it. I can then, well, dividing by 2, sorry, negating is stupid because I again get 0. The only thing I should do is multiply by 2. It will give me 1, 1, and I can of course keep increasing the last value. If I eventually negate, I will get 3, and well, I can continue by adding to the end. Or of course from 5 I could just straight continue like that. But I need to care about this. I think it's a special case. So no, this is not, this is false. This statement was false because there are more complicated cases, because every time I need to drop something from the beginning, it's not just, you know, it's obligatory to drop. So I cannot add here 5 elements and here drop only 4 or 3. I will only iterate over where the first element of new sequence, where it is in the old sequence. Or maybe it's a completely new element like that. This is possible as well. Can I do that? Can I have this as a substring? No, because it's impossible for me to get rid of that. I cannot cut from the right. So the first comparison should happen there. And here, if this part matches and this one either matches or we can increase it. In some cases we will be able to do that. Okay, I'll copy paste this to the actual thinking part, and let's start coding. Alright, test case. We read two binary strings. For each of them, I will have a function and it will just give me the sequence. And what if this is 0? This is a special case. If the first digit is 0, this is only possible when n is 1, and let's say that then we return an empty vector, but yeah, it's a very, very special situation. So if I just return a vector with value 1, it will be, my program will think that this is just 1, a single value 1, because other than this special case, the first digit is 1. Other than this, we have blocks. For every digit, increase it by 1 if this is the last digit or the next one is different. Then do that. This is a very nice code for grabbing sizes of blocks of consecutive equal values in the sequence, or here binary string. Let's test this real quick, or I can do it here. See if it works. 1 3 1 and 3. 1 1 2 and 3. Cool. 1 1 1 1 and 1 1 2. And do we have that empty line? Oh, for empty line I don't print because it's here, so it's all right. Then this 2 1 1 2, yeah, cool. How to know if the current approach will yield a solution? Intuition and years of practice. You try various things. Same in, I don't know, math. You need to solve an equation or some more tricky problem. How do you know that it will work to use some kind of formula? Because you used it in the past and for something similar, I guess. What is progress so far for C? Have tourist, interesting nickname. I think I came up with a solution and I will need to focus on this thing I wrote there. Well, if A is B, do I need any for that? For sure, to do handle empty sequences. This means 0. This represents 0. Other than that, I need to try to start the next sequence in every possible place in the first one. Maybe even just outside. We'll see. This index here is the start. but we need to guarantee that the second sequence doesn't end too early. The difference of sizes here was 2, so I started at least from there. I shouldn't do it like that because I will get some nasty signed overflow. Size is very tricky in C++. Right now I'm sure that I can fit, and there, as long as they have common elements, iterate over that. If start I fits in A, because this is still possible. Now I need to check that those two will match. If that. Now this is index J, this is index I. I check if those two are equal. Unless it's the very last element, then something special happens. If it's the last element of A. If A of J is different than B of I, there is some Boolean flag that checks if this is good or not. Too much Java and I started writing Boolean instead of bool. Else, I guess continue, because yeah, we have a good pair. But otherwise, here this is the case with last element of A. If you're bigger, then this is bad. If you're equal, then this is good. If you're greater, allowed in some cases. If this, depending on parity of A, or if we can negate once and then change this. I also need to count the number of operations. Let's see, something like just 2 and 4. This means number of ones, number of zeros, so I'm able to do this. So if A size is even, then I can just immediately increase the last element. Easy, just multiply by 2. And here, only possible to increase last element if we first negate. For those who are joining the stream, by the way, I'm solving Google Code Jam Round 1C, which happened today, earlier. I didn't participate because I already advanced to round 2, thanks to performing well in some previous round. And I'm solving the last third problem out of the problem set of 3. If I do this below, let's say 1 hour, I have this timer here, right? If I don't exceed 1 hour, I think I would win the round. So this is the goal, be below 1 hour. 11 minutes left. Okay, if we first negate, in particular, start must be at least 1, right? because if this is the case, then I cannot cut at all. What if there is just one element, like 1, 1, 1? Yeah, then we cannot do anything about that. Here we cannot first negate. All of this should be a function. I have so many breaks, continues. Shouldn't it be a function? No, I don't need a Boolean flag anymore. Code will be a little bit faster. Not faster, nicer. And, well, for the sake of speed, let's do this. Not to copy by value, but it shouldn't matter. Limits are very low. Hi, Timothy. And now instead of this, it's always just return false. Okay. And I need to count the number of operations needed. One needed for every cut, and one needed for every increment. Maybe this function should count this, and instead of return return false, I will return -1, which means it's impossible. Infinity of 1 billion is more than enough. Actually, it's a little bit stupid. I should have used here infinity as well. Infinity will represent impossible, because we minimize the answer. So infinity is a better neutral element. Okay, now if start greater than 0, so like here, when can I do that? Well, sometimes I will need to create a lot of numbers. Let's think for a moment what happens when they match. What's the strategy here? We can start producing this number depending on the parity of A. If the number of elements here is, let's see, from 2, 4, those are 0, so I can start incrementing that. Here I cannot start producing anyone, need to negate. And from this we will be left with 4, and then we can keep adding the next value. But if we start with 2, 4, 5, we can multiply by 2. And then we will have 2, 4, 5, 1. So we can immediately, without cutting, we can start building the next value. And once we build it, we will need to cut, which destroys the first number. And what then happens with the parity? Oh, the parity is good because it's just like here. So if we start from odd, then we first add, then erase. So it's possible to just add a single value and not cut anything. So if we cut 5 elements from the left, we can create most 6 to the right. This is if we start with odd a.size. And if even a.size, we need to first cut and then add. So it's like this. And it changes, I think, depending on this situation where we need to first increment this special element. Because here it's easy if a.size is even. Right? Did I say it's easy? Yes. But if it's odd, then we increment. And does it hurt in any way? Oh, you need to first multiply. No. If this, in this case, if you need to modify the last value, you need to cut, so negate. You will then have 4 and 5. And then you can change this, multiply by 2, so increase this. Maybe multiple times, and then finally negate. Then you have 6 here, and you can continue building normally. Is this really that bad? We can get to this state, so this means we cut 1 so far, cut 1, increase the last, create nothing new. Or we can cut 2 elements and then create 1 last. All right. If a.size is odd and we need to increase the last element, then we have this unfortunate situation. This is really stupid comment, but I will understand what's going on. Cut is just start. Build new. What is build new? I think this. So if b and a.size is equal, then it's 0. Then it will be start. Yeah, looks legit. As always in C++, you need to cast size to int to avoid some strange things happening, because this is signed int, not unsigned int. I mean, not, sorry, it's unsigned int. This is bad because cut must be at least by 1 bigger. But in other situations, we use that. If odd, then build is greater than cut plus 1, then it's bad. It will be so easy to make a mistake here. I don't think I'm achieving this in 1 hour. Maybe, I'm close. Okay, okay. Oh, I didn't handle 0. That's bad. take this element from the end, this would be the last one, and this will be ith last one, because we create those to the right, and also we cut some number of times. This will be related to cut and build. We can cut 5 times and create 3 times. So almost always we just do this. Maybe some more. Okay. And one last thing is that I think that we should also consider this start, where we are just outside of A. I think that stuff will work. Other than handling 0, I think we're done. Let's see if we are correct, at least for some sample tests. Oh, I already had this test. AJ greater than B of I. The one in B, in the new sequence, must be greater. 432. Okay, not bad. This is okay. The only 2 cases where we are wrong are those with 0 in the input. If there are 2 zeros, there is sadly a case where we will need to go through 0, like to get just from 3 to 5. I can make an if and say what happens if I need to get from 0 to somewhere, or from somewhere to 0, but there will be cases where I need to get through 0, and maybe even that kind of says that. But let's say I need to get from just 3 to 5. What do I do? Those are 3 ones, and I need to get 5 ones. I negate or cut. And instead of empty sequence, I get kind of an empty sequence, that's just 0. Oh, maybe everything magically works. Why is the answer impossible? Why did I say 0 here? This is empty. This is 1. Size is indeed 0 and then 1. Okay, I crossed 1 hour, sadly. I think I can still get the first place, but this would be a nice, I don't know, benchmark, goal, round time. Why do we get answer 0 in this case? I'm going to just create a new test with only going from 0 to 1. Start is 0, so this should be 1. I should get the last element, unless something is negative. No, nothing is negative. So what's going on? Build is 1, so there is that last element. Why is that 0, not 1? For build equal to 1, I need to get the last element. The best debugging method, just print stuff. Right. Wait, I don't get there? What? The solution is easy or difficult? I don't know, you tell me. Return false, what is that? Well, false is indeed 0. Okay. It thinks that it cannot go from 0 to 1, maybe because of parity of A. If we have 0, it needs to understand. It thinks that it's a situation like this one, where we increase the last element. But actually it should treat it like that, just with one extra operation. If you have 3 and you negate, you get something empty, and you need to spend one operation to now negate this and get 1. And normally you would think that you have here one operation and instead you spend 2. And a.size doesn't work, does it? Maybe it doesn't work only for if we start with empty A. Is this the only case where I need to go for 0? Do I really need to go for 0? I can, from 3, I can get 3, 1, and I can then negate. This is as efficient as I can get. Same way in the other direction. I can here keep adding and then cut. Then maybe I just need ifs for what happens if the starting or final string is exactly 0. I think that's right. First, uppercase, yeah, uppercase. All right, everything is good other than one of the cases where we start from 0. And I just need to say that, wait, from 1 you cannot get to 1, 0, 1. Oh yes, it's impossible. It works if the second element is 0. It works if both elements are 0. It only doesn't work if the first element is 0. Then we need to negate first. Unless B was the same. If B is also empty, then we need to say 0. Otherwise, there is extra operation for the first one, and we change 0 to 1, and then we will never get to 0. I think we are done here. With the time of 1 hour and 10 minutes 25 seconds. While waiting, I can as well just test. For negate, add two zeros, negate. That's 4 indeed. Yay! Done. Stop the timer. I should have stopped half a minute ago. Would this be enough to win? So if I didn't make mistakes, then yeah, I would beat this time. 1 and 11. But I had, well, first, I claimed that I wouldn't have that if this wasn't the stream, because I would copy paste my template. I just wanted to test this environment, and I forgot a hash. I never write it from scratch during a contest. I just copy paste the other main function where I already print this case hash number. So I say let's not count that. But this was a normal mistake, where in one place I used long instead of int 128. So my time should be 1 hour and 14 minutes, and that's second place. Well, good enough. Are you going to explain the solutions? I guess we can do that briefly. Is necessary other test case? You don't need a test case function, but you need to print case hash something. Sample file counted as a penalty? I don't know. Good question. Use English in the chat. Only English in the chat. Separate functions to read write in 128? Yes. And I needed one to write, so I multiple times grabbed the last digit by using x modulo 10, and I put that in a string, then I reversed it. So, solution summary. Problem A. There is somebody will take a random number from 1 to k. Let's take an example of k equal to 8. 1, 2, 3, 4, 5, 6, 7, 8. From 1 all the way up to 8. And some numbers are already taken. And now you need to choose 2 of the remaining numbers to maximize the number of places that are closest to you. For example, let's take that I take those two slots. Then my score is 3 because for, let's say, for this guy, this one and this one, I'm the closest to this cell. I'm the closest to this position. I don't get score for this cell, for this position, because I'm equally close as this already chosen X. This X is a ticket, a coupon by somebody else. So here my score would be 3. Instead, it's better to move this dot there. I should place dots like that. And now my score is 4. There are 4 positions such that their closest, some yellow dot is closer than any X. And how to best put the yellow dots? If you can put it just after the last X, so the candidates are just after the last X, just before the first X, and for this you get the full suffix or the full prefix, or when you look at any interval between two X's, you can take the last position or the first one, and then you will get half of this rounded. It's the difference between those two positions divided by 2 rounded down. I just thought about examples with size 1, 2, 3, 4, and this formula worked. If this position is I, this one is J, then the number of positions, blue positions you can get here is just J minus I divided by 2 rounded down. And you are also allowed to put 2 yellow dots in one range like this, and then you get the full range, J minus I minus 1. Those are possibilities, so I consider what I can best do with a single dot somewhere and single dot somewhere else. That's one possible answer, or I just put 2 yellow dots in the same range and then I get the whole range. Rounded up? No, rounded down. For example, here J I J. The difference J minus I is 3, and by putting a yellow dot here I will get only this one position. So it should be J minus I divided by 2 rounded down. In this case it's 1. I used the difference between positions of those two X's. Which app do you use? OneNote 2006 or 2016, one of those two. I think 2016. That was A. Problem B. I don't really have a full proof of this solution, but you're not required to produce a proof. You just need to get a program that works. You're given a number, let's say that's 68000, and you need to find the next number after this one, such that it's written as some starting value, like 50, and then you keep writing the next value, 51, 52, and so on, and you want this to be greater than that, but not very much greater. You need to find the next number after 68,000, which is representable as consecutive values concatenated with each other. For 68,000, it's optimal, apparently, looking at sample output, to start with 7 and then keep writing 8, 9, 10. It's nice because you get something of the same length and only slightly bigger. My solution is the following, but I don't have really a formal proof, just a very good intuition that it should work. There is some number in the input. Let's say it starts with 5, 2, 4, 1. For every prefix, like this one, I consider that maybe I will keep those digits and I will keep using this number, 5 to 4, then 5 to 5, 5 to 6. Eventually I will get something bigger than this, and this is my candidate for the answer. There are cases where this is stupid because here the next digit is 9, and then with this 5 we don't really get something bigger than that, so this is bad. Instead, I will use this prefix +1. Then 5 to 6 and so on. keep concatenating every next value, then 5 to 7. And this should fix the issue of this suffix starting with something big, or just this suffix being big. Again, you might not hit a good length, maybe you will get too long of a number, but this is just one of candidates for the answer. For every prefix we will try that. Also we try, just to hit various lengths, we try that maybe it's good to start this with 3 nines, because then I get 1000, then 1001 and so on. Or maybe we should start with 998, because then once more we have something 3 digits long, and then 1000, longer number. So to get those numbers of various digits, I try here 999, 998, and so on, up to 999 minus 30 I chose in my code. So I try 30 biggest prefix for this size. So here everything from 969 up to 999, or maybe starting from 970, because they will, when you keep repeating this number plus 1 plus 1 plus 1, you will eventually kind of overflow it. You will get number of bigger length, and you will get a nice variety of numbers here. And finally, I try starting with 100, with number of this length, but just a power of 10, 101, and so on. And I claim that those are the only reasonable candidates. Because, you know, if you start with something else, like let's say we start with 250 and then keep repeating it, then you will get kind of the same value as this one, but worse. Right? You will get the same length with the same number of repetitions, but this number is always smaller. And it's not that 250 as the prefix will help you to be bigger than 524. So this is, let's say, sketch of a proof. You need to also think what happens if here we first take like 650 and then keep repeating it, 651 and so on. But then I claim it's better to start with 970, because with 970, sorry, what? No, I'm stupid. No, it's better to start with 525, 525, yeah. So with this number plus 1, because again, by repeating 650 versus 525, you will get the same length. You will not overflow it to get 1000, but this number is smaller, so it's better. It's closer to the given number. Okay, let's say this is end of proof. That was problem B, and finally, no, I want to scroll to the right. Problem C, I guess the only hard problem, where we needed to transform one binary string into another with smallest number of operations. And when we look at one binary string, we have two possible operations. We can either multiply it by 2 from this guy. Well, either you will add 0 at the end. This is multiplication by 2, and you can keep doing so. You can do it multiple times. Just one operation is multiplying by 2, so adding 1 0. And alternatively, you can negate this number, and you will get zeros you skipped, and 1 0 1 0. From this white number, you can get this negated shorter one, or you can get this number with extra 0. You need to, with shortest number of iterations, get from one binary string to the other. The lengths are quite short, both are just 100. I think that my solution is in complexity n square, by the way. O of n square. I didn't say that for the previous problem, but here, because we try stuff of every prefix length, my solution, the length of a number is related to logarithm of that. So my solution is logarithm of y, and then for every prefix I try like 30 values and I keep repeating them, so it will be log of y square or maybe cubic. I think that's my complexity for problem B. For problem C, I will have n squared. Why I don't use CodeChef? That's not true. I do use CodeChef. What do you claim? I don't have an account? I never participated in a contest? Why you don't participate in CodeChef? And what do we do? Yeah, because we only add zeros at the end, or we kind of cut out the first part. Here we cut two ones and we leave this but flipped. Then I figured that what's very important are, this is still C, are lengths of blocks of consecutive same bits. This I would represent as 4 consecutive ones, 3 consecutive zeros, 2 consecutive ones, and here let's say 2 consecutive zeros. And negating is just cutting the first element, and you will be left with 1 1 1 0 0 1 1, which is exactly binary string described by this sequence 3 2 2, because there are 3 in a row, then 2, then 2, and you can add 0 at the end, which just increases the last value, unless we have something like that where the last bit is 1, then multiplying by 2 it creates a new value here, a new block size, and it makes it 1. This distinction between whether this last bit is 1 or 0 makes that problem more complicated, I must say. But the main idea is then that we should look at this sequence like 4 3 2 2 of the starting value. We get some binary string that we want to get, the target string, and we also represent it as this sequence of block sizes. Let's say this is 3 2 5 and 7 and 2, and the question is how to get from this sequence to this one. Then I try aligning them in every possible manner, like including this one. Oh, this is a strange comma. And then I say that I will, if I want to transform this sequence into this one with exactly this alignment, it means that I will cut this 4, so I will negate once, but other than that I will just add stuff to the right, if possible. And those numbers must match. It's not that I can change the interior of this binary string. I only can cut from the left, or I can add to the right. So 3 must be equal to 3, 2 must be equal to 2. Here we have a mismatch, but it's okay if I can here at the very beginning multiply this by 2 multiple times. So add 0, add 0, add 0, and now we have 5. So the last number in most cases I can increase, not decrease. If this was, instead of 5, if this was 1, then we couldn't do this change. We cannot cut the last bit. That's impossible. But a 5 here is fine. There are some other conditions, like you cannot really add a lot of elements there, especially if I add here 1 and 1. Let's consider this simplified case. I will change this 5 to 2, move those. Let's say you want to change yellow sequence into blue. How can we achieve that? We can, first, if we add more zeros, it will just increase this value. So we need to, as the very first operation, cut a 4. Then we can, to the sequence 3 to 2, I can add a 1 at the end by multiplying by 2, and then I can keep increasing it, eventually it will be 7. But then if I want to access the rest of the suffix I desire, I would need to cut the first element. So this is bad. And from this we get a condition, something like prefix cut, how big prefix we cut, must be greater or let's say equal than suffix created or suffix built. It depends on it depends on the parity of this a dot size. I mean, it depends on the parity of the sequence, yellow sequence, which just affects whether the last bit is initially 0 or 1. And it turns out that it's also important whether this 2 we need to change to something bigger, because in some cases that's a little bit more annoying. But let's say that this is required, everything here must match, and the last element can only increase. Then the number of operations used is the difference between those two elements, because we need to increase by 1 that many times, plus the sum of values in the suffix, plus the size, the number of times we cut, so the number of erased elements from the prefix. This is the number of times we negated. And we also try every possible alignment. like this, including this one where this new sequence is just strictly outsides. It's possible that no numbers match and we just need to cut 4, create 3, cut 3, create 2, cut 2, create 2, and so on. Of course, this is impossible because this suffix build is too big. Per one cut, I can only create one new number to the right, new block of zeros. But this maybe would be possible. Done. Maverick, very comfortable in Python. Should I switch to CP or continue with Python? Depends on what you want to achieve. If you want to get to the very top of competitive programming, you need to switch to C++. But for 99% of people, I would say you can just do Python. If it's your hobby rather than, really a sport that you're dedicated to and you want to spend 30 hours a week and just become the best, not caring that much about other things like your job. Why not find company? Yeah, you need to read FAQ. I like teaching. We are done. Also, if I told you previous stream about those classes that start next week, every Wednesday. How do I want to now say that? Okay, so short info just here. In May, every Wednesday, there will be 1.5 hour class or lesson for a group of around 15 people. The price is $10 per lesson. If you're and there are two groups. One is for Codeforces users with rating of around 1100 to 1300. This is group 1. Let's say max rating. And group 2 is recommended for people with rating around 1500. Let's say 1400 to 1600. And later the lessons will be uploaded to YouTube anyway. So, if you don't want to pay, then just watch on YouTube later. But if you want a little bit better experience, and well, this is quite cheap, then go join. All the info and now registration link you will find on Discord in announcements. And lessons will also be conducted via Discord. So at least this is for May. This is only May. Later I will redo this. I will repolish it in some way. 4 lessons in May, you need to pay $40 and you will have access live to those 4 lessons. And in May it will be on my Discord server. Maybe after May I will make a new server, or we will switch the format. Maybe it will be Teams or private YouTube stream. I'm not sure. In Discord server, in the link I gave you, in the announcement section, there will be all the details, like how to pay, a little bit more about style of lessons, all that stuff, and the timing. It's every Wednesday. It's after Europe afternoon, India evening. A little bit earlier than the stream today, like this. I will present in C++, but I don't mind you using Python, as long as you're able to understand what's happening, especially for the lower group, because I guess so. I'm not sure in which group it's more important. Like if you're watching my stream and you don't have big issues with understanding what I'm talking about, well, the stream today was harder than the classes. Maybe it was closer to this one. Yes, I know Python. One question missing in the FAQ. Twitch affiliate. I don't want subs, I don't want you to subscribe and pay $5 a month. That's one thing, and the other is that then I couldn't double stream to YouTube. Indeed, I should add it to FAQ if it's not there. Cool. So again, join the Discord if you're interested in those cheap paid classes. If not, still join the Discord to hang out with me. Thank you all for watching this this stream. I will add the codes to GitHub repository, and in YouTube in the description there is always a link to a GitHub repository. So if you want to go through my codes, you'll find it there. Quick look if maybe somebody else is streaming. No, they are not, so nobody to rate. Thanks, bye, see you Tuesday. One GitHub repo? Yeah. Why would I need two? I mean, for YouTube stuff, I just have one.